everybody, and welcome to Leading Entrepreneurs of the World. I'm Stelios Hatzakis, CEO of One Business World. Leading Entrepreneurs of the World features entrepreneurs, founders, and business leaders presenting on cutting-edge topics and the latest industry developments. Today, we're very pleased to welcome global entrepreneur Chad Wasilenkoff. Chad is the founder and CEO of Helicoid Industries. Chad is a senior executive with verifiable year-after-year success, achieving revenue, profit, and business growth objectives with startup, turnaround, and rapid change companies. Chad has received a wide range of recognition and awards. He's a winner of Ernst & Young's Entrepreneur of the Year Award, RISI's list of 50 most influential people in the global forest industry, and Business in Vancouver's Top 40 Under 40, and has an established media presence on channels including Bloomberg, CNBC, BBC, CNN, among several others. At Helicoid Industries, Chad and his team have patented technology exclusively licensed and used in the composites industry. Helicoid Industries emulates the incredible strength of the Mantis Shrimp in order to make composites that are lighter, stronger, more impact resistant, and all at an overall lower production cost. Through licensing, Helicoid Industries targets numerous industries simultaneously. From its infancy, Helicoid Industries has also maintained a solid sustainability approach, being committed to developing solutions that will improve the well-being and comfort of people while reducing the socio-environmental impacts of composite products, their initial manufacturing, and their disposal. Chad, it is great to have you here with us today to hear more about how we can learn from nature to develop disruptive technology. Welcome to Leading Entrepreneurs of the World.
Thanks, Stelios. It's a pleasure to be here. So as Stelios mentioned, my background is fairly entrepreneurial. I've built and grown more than 30 companies, taken more than a dozen companies public. I've raised over $1 billion for those various opportunities around the world. I've had thousands of employees, everything from owning a banknote mill in Switzerland, where we're the sole maker of the Swiss franc, wallpaper mill in Germany, where we grew that to over 60% market share globally before selling it to a New York Stock Exchange listed company. I've had uranium, tequila, software, and various other opportunities. From that, I've most recently gotten involved in biomimicry and companies or opportunities that evolve from nature. The way I found this opportunity was I was volunteering at the Business and Entrepreneurial School at a couple of universities here in Southern California. And after talking to them, I asked, what's the most interesting, again, disruptive technology that's ready for commercialization? And they quickly all said it was this helicoid. And from there, I was able to work through a license agreement, and we continue to grow and build this company. So that, maybe I'll touch a bit on helicoid. So as I mentioned, it's a biomimicry story. So biomimicry is when you design and produce materials, structures, or systems that are modeled after biological entities or processes. So as we've seen in nature, things evolve over hundreds of millions of years. And with that, obviously, they sort of perfect these opportunities. And then we can take those, translate them into real life situations, and now commercialize them. Just a couple of examples. One being Velcro. Again, this all started by researching and understanding how burrs and spurs worked and would attach to animals or clothing and things like that. Replicating or mimicking that ultimately evolved into Velcro. We look at sonar, whether it's from bats or from dolphins or other mammals and marine creatures. Again, that has evolved into the sonar we use today in submarines and other applications. So if we look at our technology and our Manta Shrimp, as Stelios mentioned, ours came from this Mantis Shrimp, which evolved over these hundreds of millions of years to be incredibly strong composite materials. So with that, I'll show a short video that actually was put together by the Biomimicry Institute.
This little critter is the Manta Shrimp, perhaps better known as the Smasher Shrimp, due to its powerful front clubs, which are used to obliterate its prey. So, how is it that this shrimp is helping us to design stronger and more lightweight materials? A decade ago, scientists began to unravel the mystery of the shrimp's success. They discovered that the material that makes up the clubs was arranged internally in a spiral-like structure known as a helicoid. This is a fantastic shock-absorbing structure formed from sheets of parallel fibers which are stacked and rotated, allowing it to dissipate energy efficiently. And now, by reverse engineering this natural architecture, the company Helicoid Industries have been able to incorporate it into modern designs of composite materials. The benefit of using helicoids is that they have a very small surface area and are formed from far less material than solid. By using them in composites, Helicoid Industries can massively reduce the amount of raw materials used in production, making them lighter with a smaller environmental footprint, all without sacrificing strength. Their plan is to incorporate these natural structures into materials to build things like wind turbines, cars, sporting goods, and eventually into aeroplanes. These enhanced designs would allow for more fuel-efficient vehicles, as well as allowing for longer and stronger turbine blades, increasing their overall energy output. Not bad for a little shrimp.
So that's our Mantis Shrimp, and that's how our technology evolved. So if we look at that Mantis Shrimp and the evolution of it, it's actually as described, those clubs at the front of this Mantis Shrimp. They attack underwater prey at faster than a .22 caliber bullet. They pulverize that prey, and they do it tens of thousands of times without damaging the club. And it was obviously the research into that is where they found this helicoid architecture. Now we've mimicked that to now make what we call our composite helicoid material. Here again, just a short video of these clubs at work that again would be these rapid underwater attacks. So when we look at our technology, again, it is all patented, and we have exclusive global rights, as well as several other patents of our own we're working on. We can make any and all composites lighter, stronger, more impact resistance, more durably, more sustainably, because we can use less raw material to get the same performance. And because of that, we can do all of this at a lower production cost. If we look at the global composite industry, it's over $90 billion and expected to grow to $160 billion by 2027. If we look at what's been driving the success and growth of that industry, it's basically improved performance and reduced weight. The challenges they face, though, are cost. To get a composite is typically more expensive than using a mono product, something like a plastic, as an example. Also, carbon fiber as a composite can have some recyclability challenges. Utilizing our technology improves all of this. We help further drive upon the successes, and we help eliminate or reduce the various challenges. So taking this shrimp and emulating, the research that has gone into this has been by over 70 researchers, 16 universities worldwide, 14 years. During that research, they've also found 50 other organisms in the world that utilize and benefit this helicoid architecture. So there's a beetle in California that you can drive over with a steamroller. Several plants around the world that are known to be incredibly strong, tough, and stiff. And again, through research, they found out they too have evolved with this helicoid architecture. So we spent over $12 million to get to where we're at now, and now looking to commercialize it. Again, there's an originating patent by UCR in the regions here in California, which we have worldwide exclusive rights to. We've also filed some of our own patents. So as mentioned, the technology and the excitement behind it is the architecture. So we can use the exact same material out of the same box, and just by putting it in this spiraling rotation, it improves the physics and allows the energy to dissipate. You can imagine what you might normally see with carbon fiber in an automobile, such as a Mercedes or BMW. It has that crisscross pattern. So there's very small surface area between two fibers where that energy would get transferred to the next layer. Using a helicoid, there's very large surface area because it's a small angle of rotation, and that transfers that energy, allowing the energy to be dispersed and reducing the catastrophic failure. So when we've done all our testing and various opportunities we've looked at, the benefits are staggering. So taking the same material, whether it's carbon fiber, fiberglass, or Kevlar, out of the exact same box, the same manufacturing processes, and just comparing it to utilizing now just the helicoid, so just the architecture of the way it's laid up, here's some of the benefits we've achieved. We can delay catastrophic by 74%. So in some applications, people are looking to, they don't need to improve the performance, such as an airplane fuselage. It's already safe enough. So they can reduce that weight significantly to get the same performance. Other opportunities like a bulletproof vest are looking for more performance without increasing the weight. So again, they can get significant improvement that way. You can improve impact strength by 50%, load bearing strength by 92%. That obviously is very important and impactful in the construction industry, especially with all the infrastructure builds that are planned here, especially in America in the coming years. But this load bearing applies to other aspects as well. We've done prototyping and are finalizing the manufacture of carbon fiber hockey sticks. And it's that same load bearing when a player utilizes the stick, it hits the ice and it actually bends the stick before rebounding and straightening again. And again, that's a load bearing aspect. So again, there are many other uses besides just industrial. Peak transverse load by 73%. In plane surface delamination, we can improve that by over 100%. Residual compression strength, so even after an impact, as long as it's not reached catastrophic failure, we're 20% stronger. And again, through thickness damage reduction by 50%. All of these very impactful and very much needed throughout the composite industry. So if you look at our business model, we're taking a two-pronged approach. Originally, we wanted to get into manufacturing, but realized rather than trying to compete with all these incumbents, we wanted to partner with them. They have the customer base, the knowledge, the experience, and they can utilize and leverage our technology. So someone like a Boeing or an Airbus or other large automobile manufacturers would just look to license our technology and implement it in their various products. Whereas other smaller companies, if they're a cell phone case manufacturer, they're not looking to license the technology. They just want to buy helicoid products, such as a carbon fiber, where it can be lighter, stronger, more impact resistant. So again, we're looking at both approaches. This allows us a much faster and more diversified revenue base. We get to collaborate rather than compete with these multi-billion-dollar large-scale companies. We get to go after numerous industries all at once. We also avoid the capital-intensive nature of owning the manufacturer facilities. And even after the royalties, because there's a cost saving on the raw material, we can earn this royalty and the overall manufacturer can still earn a larger profit. Mentioned before our patents. So again, there's an original underlying patent from the UCR or the Regents. But we've also filed several additional patents, also now including the various manufacturing processes. So some of the quick applications we're focused on right now, obviously we're targeting these due to faster penetration, due to quicker and less expensive prototyping, because most of our customers will want to do some prototyping to confirm the performance benefits before implementing it, and less regulatory hurdles. So our first three industries, one is the wind turbine blades. So wind turbines, by utilizing our technology, can probably see a performance increase in the 15 to 20% power production performance over the lifetime of those blades. There also should be a significant cost reduction in putting these blades in place, because if we can reduce the weight of the blades, then you can have lighter towers, lighter other structures, foundations, and things like that, reduce transportation costs. So we've just initiated a $300,000 Cal Testbed grant that we were awarded, and we're just finishing off the start of our blade production focused on the leading edge protection. On automobiles, we're working with several global manufacturers of automobiles, including one that is making a chassis at full scale, and we hope to have that on the roads later this summer in prototype form as they try to launch this new electric vehicle. Sporting goods, we probably have almost half a dozen different companies, global leaders in what they do, that have gone through various rounds of prototyping and have seen the performance improvements already. So we're working with hockey stick companies, golf clubs, baseball bats, tennis rackets, and various others. Just these three industries alone are expected by 2025 to be a $50 billion industry in terms of their composite use. And again, we can show a material impact on all of those. So as mentioned, our wind turbine, and our focus is on this leading edge protection on that front where the erosion occurs due to sand, salt, wind, and other debris. Can be also lightning strikes. And so again, a massive improvement in electric production can really change the economics for the wind turbine industry. So again, we've got a $300,000 Cal Testbed, and we're working with two global leaders on implementing that. On the automobile, on the bottom right, you can see that chassis that's being made as our first endeavor into the full-scale prototype. Again, if we can help reduce the weight without sacrificing performance, a 10% reduction in vehicle weight results in a 6 to 8% fuel efficiency improvement. We're also working with a global leader on hydrogen pressure vessels, and we've already made prototypes for that for the hybrid market. Sporting goods, as mentioned, it's a $4.5 billion industry alone with a 20% growth rate. Very similar if you think about a golf club, a helmet, or a hockey stick. It's repeated blows similar to that Mantis Shrimp. And again, our technology can have a huge improvement. These are just some of the industries, as mentioned, that we're already working on prototypes with. In terms of the team, as I said before, I'm the CEO and founder. I bring the entrepreneurial side and the finance side. Pascal is our CEO, or sorry, our president. He's based in France. He's got 25 years experience in the composite industry. Doug McCarville is our chief technology officer. He actually did the due diligence on the technology for me as we were building out this company. He's 35 years at Boeing, all in composites, has 64 composite patents in his name. And again, he's since joined our company. He's very excited. Bill Spathoff, our CFO with 40 years at Citibank. David Caselas is the lead inventor, and he's on our board. Lorenzo just joined us. His background was also in the academia, working at Imperial College, which is known to be one of the global leading areas for composite research. And he actually did his thesis on helicoid structures. He, again, just joined us here in February. Anthony's got a lot of composite experience in wind turbines and automotive. And Anita helps us on all our marketing and communications. So again, just some of the key takeaways of helicoid and the exciting disruptive technology that we have. Obviously, we can make any and all composites lighter, stronger, more impact resistant, more durably, more sustainably, and as everyone's always focused on, a much lower production cost. We're disruptive to a huge industry at 90 billion and growing. Unlike a lot of startups that usually take a bit of time, we already now have the team in place to build out this company and succeed. So thank you for your time, and I turn it back over to Stelios.
Chad, incredible work, you and your team, disruptive and transformational work you and your team are doing with at Helicoid, and it looks like your research, development, and application of the Helicoid design will truly transform many industries and products. You shared with us some info on the various applications of the Helicoid design. How important would you feel strategic alliances with automobile manufacturers, sporting goods companies, among companies from within other industries, may be for the expansion of Helicoid Industries and the application of Helicoid design in all of those kind of product areas? Could you please expand a little bit more on how you're planning to establish those relationships to further expand your outreach?
Sure. Yeah, so that's part of our business model, again, is to collaborate with all these manufacturers that are global leaders. They're the incumbents. They have the channels already open. So rather than trying to compete with them, so rather than trying to make our own hockey stick, we're working with the global leading hockey stick brand. Again, they have the reputation, the market share, the distribution network. We could just have a small, minor change to their stick, which will actually bring down their costs, make them more competitive, and let them drive forward, versus trying to, again, start our own manufacturing facility, building those hockey sticks and growing it that way. Same thing with the automobile side. We're working with numerous partners. They're doing the prototyping. They've got, obviously, we're not going to revolutionize the entire automobile, just certain pieces and parts that are looking for reduced weight, increased strength, or impact resistance. And that's where our technology can benefit. So again, we're just looking to license to those various incumbents. But we're also at the same time needing to manufacture some helicoid-based material, because as I mentioned before, a cell phone case manufacturer doesn't have an R&D department. They're not doing all kinds of different layups with carbon fiber. They just want to buy the material. And of course, when we approach them and say, would you like a lighter, stronger, more impact resistant cell phone case, and you can get that at a lower cost, of course, there's interest, and we're getting very good traction. Even though we just started the company last year, obviously it was a challenging year with COVID going on, and we couldn't make sales calls or attend conferences and things like that. But it's just been really word of mouth, and people are hearing about the applications of this technology. And then with more and more prototyping, we're demonstrating it in a lab, and hope to actually have it rolling out in many products by the end of this year.
Absolutely. And could you please expand a little bit more? So you established, let's say, a relationship with an automobile manufacturer after showcasing the powerful capabilities of the Helicoid design and architecture. What would that entail as a process of implementation for that manufacturer? How easily would they be able to implement this design and this technology to reinvent the way and change the way that they have been doing things, to be doing them this way that's more effective using the helicoid architecture? Would you be able to expand a little bit more as to how easily this could be implemented for the manufacturers themselves?
Sure. That was actually one of the things that got me excited about this technology, is how easy it is to implement across all industries. So as an example, if we're trying to create a new fuselage for an airplane or a bumper for an automobile, we're not asking them to go into certain titanium magnesium alloy with a honeycomb structure, something they've never dealt with. We're just telling them to use their existing manufacturing equipment, the existing carbon fiber or fiberglass, if that's what they're using, the same resins, the same cure process. So everything is the same. It's just the initial layup that changes. And with that, they have the choice then. Do you want to use less material to save on weight and get the same performance? Or do you want to use the same amount of material and improve the performance? Again, depending on the application, that's the decision they'll have to make. So the implementation is fairly quick. The proof of concept also fairly quick. And then it's just regulatory hurdles. So you mentioned automobiles specifically. We're working with one California company here. They're building the full-scale chassis and battery components. Then they'll have to go through crash testing. So that's out of our control. They'll manufacture several of these chassis utilizing the helicoid, get their regulatory approvals, certifications that are required, and then they'll be able to roll it out in automobiles. That's again why we're also focused initially on sporting goods. There's just less regulatory hurdle, less of these problems and challenges to go through. We're working with the global leader on helmets. We've already shown a 25% reduction in weight with the same performance, but now they'll go through that final certification process before it ends up in motorcycle helmets or hockey helmets, bicycle racing helmets, and numerous other applications, football helmets. So it's applicable to all of these. And again, that's one of the things I loved about it. As I said, very easy to just seamlessly fit into the manufacturing process. On aerospace, another example, a lot of the pieces and parts are made utilizing a 0 degree, 45 left, 45 right, 90 degrees, and it's done by robotic arms. So it's literally just a software change of telling the arm which direction to lay these layers of fibers in. So very quick, easy to put in place, and then get these kinds of benefits. We're actually working with the global leader in composite technology for aerospace called Hexcel. Again, we can't talk about results or what exactly we're working on, although then we're working on projects with them and they're excited about it. So it's interesting times for us.
Absolutely, Chad. And you are an entrepreneur, very, very well recognized, and even you're right now developing a disruptive and very innovative technology. And you also recently established a licensing agreement with the University of California, Riverside, to commercialize bio-inspired patented architecture and technology for composite materials. Could you please expand, as an entrepreneur who is going through this process, could you please expand a little bit more on the powerful impact of this alliance with the university and what the benefits of it may be now and in the long run?
Sure. Yeah. So obviously, universities typically, not always, but typically focus on widespread, game-changing types of technology that can be very expensive, not just time-consuming and difficult, and they'll have a lot of challenges along the way. And so I found great success in finding some of this research that's come out of universities where they've taken the long, slower path, solved a lot of issues and problems, but again, they're typically not in the business of commercialization. So you've got this great technology that's just sitting sort of orphaned there until an entrepreneur finds that technology and drives it forward. Again, trying to do this on our own, if we had just heard about this Mantis Shrimp, it would have cost $12 million and a dozen years to get it to here. And investors typically don't have that kind of patience. I know certainly I don't have that kind of patience. I'd rather wait till somebody's done all that time-consuming heavy lifting and got it to this point, and then we can take it from there. And it's a great partnership, so that they will also participate in the upside as we gain success and commercialize.
As far as, let's say, international expansion is concerned, would you be considering some similar alliances with institutions abroad?
Yes. Yeah, we're working again. Actually, we're a global company already, even though I would still consider us a startup. So we've got people in Canada, the United States, France, Switzerland, the UK, several in Asia, and we're looking to expand into Australia and India. We're in final discussions with that. Again, it's a global market, being composites. Our technology can be helpful and disruptive to all of it. So yes, absolutely. We're looking for collaborations all over the world and people to help us implement and drive this technology out there.
Absolutely. Well, Chad, thank you very much once again for your presentation as part of the Leading Entrepreneurs of the World series. Congratulations on all of your success so far with everything that you and your team are developing at Helicoid Industries. And we are very, very excited to continue admiring your growth and expansion. Thank you, and we look forward to speaking with you again soon. Wonderful, very insightful, very informative points. Thank you for being a part of it.
Oh, thank you for having me. Always a pleasure to support a great organization like yourself. Very passionate myself about entrepreneurship. So keep things going.
Thank you. Thank you very much, Chad. Talk to you again soon. Thank you. Bye-bye.